Hi, hello everyone. So this is the video dealing with section 25, graphing quadratic functions. Recall that when you have a quadratic functions, its format looks like what you see over here, right? Very much the same as when we solve quadratic equations. We have to have ax squared, bx, and plus c. Now, for quadratic functions, the only term that is absolutely necessary is the ax squared. The other two terms are, you know, either possible to appear or not. So they may or may not appear, but the ax squared is necessary. A cannot be zero. Now, the very first thing that you need to know when we graph a quadratic function is that the graph of a quadratic function is called a parabola. And it looks like one of these two possibilities. So in the first case, we have this function opening up. So we call this concave up, meaning it opens up. Now, the criteria for the parabola opening up is if the coefficient a is greater than zero, meaning positive. In the second case, we have a parabola that opens down, so we call it concave down. Now, this is going to be the case if the coefficient a is less than zero or negative. Okay? So these are the immediate two distinctions between a concave up and concave down parabola. So, but first, the graph looks like this. Now, notice you cannot graph it this way or that way, right? So this would be the absolute value function, not a parabola. So the parabola is curvier, as you can see here. All right. Number two, there is a line in splitting the parabola exactly in the middle, as you can see here. We call this the axis of symmetry. So whichever parabola you have, the concave up or the concave down, there's a line right in the middle called, and this thing is called the axis of symmetry. At either the lowest point or the highest point of a parabola, depending if you have concave up or concave down, the name of the point is called a vertex. Okay, so the vertex is either the smallest point or the highest point of the parabola. So when we graph a parabola, we are interested in the following points. I'm going to erase here for you to see. I'm going to use just the concave down example, but it's the same for both. We need to find this location here, which is the y-intercept. We need to find these two locations, if they exist, called the x-intercept. This is where the parabola crosses the x-axis. Now, it's possible that the parabola might do this, okay, and not touch the x-axis, which is perfectly fine. That case happens if the x values are imaginary, okay? It's also possible that the parabola just touches in one location, okay? In that case, you only have one root. But it's also possible that you have two. So we're just indicating two here because there may be two roots. So these two are the x-intercepts. So we need to find the y-intercept. We need to find the two x-intercepts. We need to find the vertex. We need to find where the axis of symmetry is. And then we need to graph. So I've included everything here: y-intercept, x-intercept, axis of symmetry, vertex, and graph using these 4 points. Okay? So the details are here. The only new detail that you're going to need is this. The axis of symmetry is located in this point, minus b over 2a. And then the coordinates of the vertex are here. And I'll show you exactly how to do that. All right. All right, so on the exam, you're going to do exactly in the exact same way as I am doing here. X, Y, X intercept, X of symmetry, vertex, and graph. All right, that's all you're required to do. So the questions on your workbook are already in the format that we want you to do them. Okay, with the exception of I'm going to do the y-intercept first because that's the easiest one. All right, so let's see. So here's a function. They're giving us a function, and we need to answer all of these questions. But I'm going to begin with the y-intercept. So the y-intercept, we find that when we evaluate f of 0. So all I have to do is replace x with 0. Okay, so this is 0 squared. 6 times 0 plus 9. So this is 0, this is 0, so the answer is 9. But now notice, we want the coordinates. So the coordinates is x0, y9. So on the exam, we need to see you write this. Let's do the second one. The second one are the x-intercepts. Now, there may be no x-intercept if the parabola doesn't cross the x-axis. There may be one if the parabola just touches the x-axis, or there may be two if, like the pictures you saw earlier, they cross the x-axis in two locations. We don't know, but this is how we find it. You're going to get the equation or the function, and you're going to make it equal to 0 because this is where y is 0. And then you just have to solve this. Okay? It may be factorable, it may not be. You may use the quadratic formula, you may try to factor. I think this is factorable, so we're going to try to factor. Okay? So again, the factoring is the AC method, so the product is A times C, which is 1 times 9. And the sum is B, which is -6. So let's see if this is factorable. So the possible pairs for 9 is either 1 and 9 or 3 and 3. And it looks like it's 3 and 3, but only when both numbers are negative. Okay? So -3 times -3 is +9. -3 plus -3 is -6. So this is it. So we factor this, and we get x minus 3. X minus 3 equals 0. Now, by the way, this is the exact same way you would show your work on the exam, okay? You have to show everything. By the zero product rule, either this factor is 0 or this, but it's the same factor. So we have x equals to 3. Notice you only found one value. Now, what does that mean? It means that this parabola, which by the way, look at the original function right here. Here's the function. And ask yourself, that's the first thing you should ask. Is this parabola concave up or concave down? And for that, you would look at this. This is positive, it's concave up. But because there's only one x, this only touches on x equals 3. Okay? So I've done the, but it's the coordinates. Don't forget, coordinates of the x-axis. So the coordinate is 3 comma 0. So in this case, x is 3, y is 0. Okay, so we've done the coordinates. Now let's find the equation of the axis of symmetry. This is probably the easiest thing. Okay. Axis of symmetry. Y equals minus b over 2a. That's it. That's the equation. Now, and how do I find a, b, and c? Again, it's from the equation or from the function, more specifically. So your A is 1, your B is -6, and your C is 9. So the minus B is minus 6 over 2 times A. So this is 6 over 2, 3. So Y equals 3. You have to write this on the exam, okay? Don't leave just this number 3 because we don't know if you know it's an equation. All right? Um, I'm sorry, this is supposed to be right. It's always X. Okay, X equals, not Y equals. All right, X equals minus B over 2A. Okay, so don't just write this right here because we don't know if you know it's supposed to be an equation, right? Students usually do this and they don't understand. You have to write what you see right here. X equals 3 because the axis of symmetry is an equation, right? So here, the equation. So we are highlighting the word equation because we just don't want to see a number because we don't know if the student knows it's an equation. So this is what you have to write. If you write this, then that means you know, hopefully. All right. The next thing I need to do, and almost last, is find the coordinates of the vertex. Now, the vertex has the following coordinate: minus b over 2a, and the function evaluated at minus b over 2a. Now, this may look weird, right? But all this means is whatever this value is, it's the axis of symmetry. So it's the same value. So that is here. And this function is the function evaluated at the point of the axis of symmetry. That's all. Okay. So whatever value you got for the axis of symmetry, you're going to evaluate function at that point. Okay. So here's the function again. So I have to replace x with 3. So 3 squared, 6 times 3 plus 9. So 3 squared is 9 minus 18 plus 9. So this is 0. So the coordinate, notice again, coordinate of the vertex, right? So it's 3 comma 0. Now in this case, it just so happened that it's the same, but it's not usually the case. All I have to do now is I have to get all of this information. I'm going to reduce this thing a little bit, and I'm going to graph the parabola. Now, just keep in mind, I'm doing this on this software, so the picture may not be very great, but I have to put everything in. So the very first point is, this is my y-intercept, 0, 9. I have to put the x-intercepts. There could be 2. In this case, there's only 1. So this is my 3 comma 0. This is 0 comma 9. And the axis of symmetry is x equals 3. Now, it's always x. So the equation has to be, number one, graphed as a dashed line right through the vertex, which in this case, again, is 3, 0. So you're going to do a dashed line right here. It has to be dashed, okay? And then you're going to graph a parabola. You already know in this case, the parabola is concave up. Now, the left side of the parabola is identical to the right. Okay, so all you have to do is trace a line that is a little bit curvier this way, and then go the same way on the other side. Okay. So this is the final graph for this particular prop. That's all you need to do. You need to put the y-intercept. If you have just one x-intercept, 1. If you have 2, you put 2. The axis of symmetry in this case is x equals to 3. and the vertex, and obviously the graph. Okay? Now let's do the second example. The second example is, I'm going to erase all of this thing right here. You can obviously pause the video if you want. The second example is going to be a concave down parabola because, we're practicing, so we want to see exactly what everything is. All right, so I'm going to leave it here. And we do the exact same thing as before, right? So here's the function. I can see it's concave down because a is -1. So this is going to look like this. So it's very important that you don't graph this thing wrong, right? Because, you would lose points. So I'm going to do the y-intercept first, and the y-intercept you already know is f of 0. So I'm going to replace x with 0. And obviously these are 0 and I get -8. Now, but remember, you need to write the coordinate. So the coordinate is always x0, whatever value you got. The second thing is I need to find the x-intercept or intercepts. So, and you find that by solving the equation with 0 here. You have to solve this equation. Now it looks like a quadratic, and we don't want to begin with the minus, so I'm going to multiply everything by a -1. And when I do, the signs flip. Okay. I suspect this may be factorable also, but if it's not, you can use a quadratic formula. AC method again. Sum is B. And the possibilities are either 1 and 8 or 2 and 4. It looks like it's 2 and 4, right? The product is 8. The sum of 2 and 4 is 6. So I factor that into x plus 2, x plus 4, and by the zero product rule, either this factor is 0, which means that x is -2, or this factor is 0, which means that x is -4. Now, you have to again find the coordinates. So this answer, the way, if you wrote it just x equals -2, x equals -4, you get only half of the credit. You have to write -2 comma 0, -4 comma 0, the coordinates. Okay. Now, next, I need to find the x's of symmetry. The axis of symmetry, you already know, minus b over 2a. Let's go back to the function, take a look, right? A is -1, B is -6, C is -8. Okay, so minus B minus -6 again. 2 times -1. This is 6 over -2, -3. Now, don't leave it this way. Go to the next line and write x equals that. Okay? Because we want to make sure that you understand this is an equation, not a number. 4, you have to find the vertex. Now, the vertex has x coordinate this. So you can immediately write x equals -3. And then you have to find the y coordinate, which is f of this -3. So whatever this number is, goes right here. And I'm going to use the function now to find f of that number. So here's the function. So negative, -3 squared minus 6 times -3 minus 8. This is what I need to evaluate. So this is -3 squared is 9, but with the minus in front is -9. This is plus 18, it's minus 8. So this is 10, -9 plus 10, which is 1. Again, don't leave it that way because you're supposed to find the coordinates. So you have to write right below it, right? -3, comma, 1. This is what we need to see. But we also need to see the work. So on the exam, you're going to show me all of this. Okay? You have to show everything. Now, the last thing that we need to do is graph. So I'm going to make this a little bit smaller so that we can squeeze the graph in here. Okay, now remember, you are to graph this. Do not do this or that. All right? That would be incorrect. You won't get credit for that. It has to be in a curve. Okay, in this case, down. So let's plot in the y-intercept right here, 0, -8. I'm going to say that this is here, 0, -8. Let's plot in the two x-intercepts. This is -4, comma 0. And let's say here, -2, comma 0, the x-intercepts. Let's do the axis of symmetry, which is -3. Remember, axis of symmetry has to be a dashed line. Label it. And let's put in the vertex, which I think it's here somewhere. I'm going to do it right here. And all I have to do now is graph. And my graph has to pass, I already know it's concave down, right? Because x is -2. I'm sorry, -x squared. All I have to do is graph. So and remember, the left side of the parabola is equal to the right. So here is one side, and here's the other. Okay? On paper, you would do it a little bit better than that. But this is it. This is all you have to do on the exam. All of these 4 points and the graph to graph a quadratic function, which is called a parabola.